In this video, I'm going to talk to you about geometric sequences. So here we're talking about a sequence where we are multiplying one term by the same thing over and over and over again to get the next term. So here we can begin with any first number. We call that first term a sub 1. And then we multiply by any real number to get the second term in the sequence. And then we continue to multiply that by that same number to get the third and then the fourth and so forth. The number that you're multiplying by is called the common ratio, or lowercase r. And like I said, it's a multiplication that continues to get one term to the next. You're always multiplying by the same number. Here are two examples. In the first sequence, we're starting with 40, and then 20, and then 100, and then 500, and so forth. So here we would be multiplying by 5 every single time. So 4 times 5 is 20, 25 times is 100, times 5 is 500, and so forth. Our first term, a sub 1, is 4. The common ratio is 5. And if we were to continue, the next three terms in the sequence would be 2,500, 12,500, 62,500. In the second example, the first term is 2, then negative 6, then 18, then negative 54, and so forth. Here you notice that the terms oscillate back and forth between positive and negative. That tells us that our common ratio, r, is negative. Our first term is 2, that's our a sub 1. And we would have to think about, what do I have to multiply by to go from 2 to 6, and then from 6 to 18, and that's 3. But since we alternate signs, that means we have a negative 3. And again, you can double check by just multiplying 2 by negative 3, then negative 6 by negative 3 to see that that turns again positive, and so forth. If we were to continue, the next three terms in this sequence would be positive 162, negative 486, and then positive 1,458. In this third example, we're starting with 48, and then 24, 12, 6, 3. And here we see that our first term is 48, but here the numbers seem to be going down instead of going up. So you might think, oh, well, I'm dividing because I am making my numbers smaller. While that's true, while you might think about this as dividing by 2 every single time, we always want to write our common ratio as something that we could multiply by. So if I multiplied by 1/2, that does the very same thing as dividing by 2. Oops, excuse my screen for a second. So 48 times 1/2 is 24, times 1/2 is 12, times 1/2 is 6, times 1/2 is 3, and if I keep that going, 3 times 1/2 is 3/2, or 3 over 4. Then I can, if I multiply that by 1/2 again, I have, 3 over 2, and if I multiply that again, I get 3 over 4, and then 3 over 8, and that would keep going. Now, instead of listing out terms like we had seen with the arithmetic sequence, it's helpful if we have a formula that we can use if we want to find, let's say, the 50th term of a geometric sequence. So just like we did before, we're going to use our inductive and deductive reasoning skills. We have a very similar chart here. We have n in the first column. That's just the position of the term that we're in. The notation for that term, a sub 1, a sub 2, and so forth, all the way up to a sub n, which is what we want to build a formula for. The first term is always just the first term, whatever it happens to be, a sub 1, so there's nothing to do there. But to get the second term, we're multiplying the first term by some common ratio r. So we have a sub 1 times r. And to get the third term, we multiply by r again. So we've multiplied by r twice so far. So I could simplify this expression using an exponent. Instead of r times r, we can write that as r to the second power. If we continue for the fourth term, a sub 4, we've multiplied by r now 3 times. So that's a sub 1 times r to the third. Continuing with a sub 5, we've multiplied by r 4 times, a sub 1 times r to the 4th. And you might recognize the pattern here, kind of similar to the pattern that we saw for the arithmetic sequence. Here the exponent on r is 1 less than the term number that we were looking for. So if we're looking for the fourth term, we take the first term and multiply it by r to the third power. Now, if we were looking for the nth term, we would start with the first term, but we would have multiplied by r 1 less than n times, so n minus 1 power there. So in the next video, we're going to use this formula to find the nth term of a geometric sequence. So you might want to take a moment right now and write this formula down, or actually I have it here for you as well in a nice simple case. So again, this is anytime we want to find the nth term of a geometric sequence, where the first term is a sub 1, the common ratio is r, we can use the following formula. So take a moment, write this down, and I'll see you in the next video to use it in examples.